Now all those previous ones with the cos, the sine, where I put the k in, was leading us to these ones. Derivatives of the form ax plus b, and then we're going to look at integrals of that form as well. So just as a warm-up, let's do some derivatives. If you had to do the derivative of this, well, it's a chain rule. The 7 would come out in front, subtract 1 from the exponent, but then you would do the derivative of the inside, so you'd have to also multiply by 5. So we can kind of say, more generally, I'm looking at ax plus b. A is some number, b is some number inside here. So the more general form, which I'll do here in blue, well, we'd have the number would come out in front just like normal, subtract 1 from the exponent, but then the chain rule, you'd have to multiply by a. What happens if you had that inside of a natural log? Well, we know that the derivative of a natural log is 1 over x. So if I have a 4x plus 7 inside, it's going to be 1 over 4x plus 7. And then we would have to multiply by 4 because of the chain rule. Oh, wow. Sorry. There we go. Got to maintain my color coding. Nice. That's in green. Now the more specific one, in blue, if we had ax plus b in there, well, the derivative would be 1 over ax plus b, and then a chain rule, you'd multiply by a. So we start to put this form ax plus b into every type of derivative that we can think of. Oh, inside of an e to the x. So the derivative would be, well, e to the x, everything stays the same, but then it's a chain rule, so I'd have to multiply by 10. Well, the general form then says, if you have ax plus b inside of an e to the x, it stays the same, but the chain rule, you'd have to multiply by a. And the idea of all of this is for us to develop a pattern. Derivative of sine is positive cos. Chain rule would multiply by 2. And this is the idea behind doing all of these, is to say, well, this is how mathematicians notice things, develop a pattern, and then come up with a rule or an explanation for how to do things that look similar. And the thing that's similar in each of these is that ax plus b, some sort of line, right? mx plus b, ax plus b. Same thing with this last one. F prime of x, the derivative of cos is negative sine 6x minus 13, chain rule, so you'd multiply by 6. And the more general one, oh, yeah, totally forgot that bracket. Thank you for noticing that. Oh, and I forgot the times a, like, I was like, you were like, I thought I saw a pattern, and then we got to the last one, and it didn't work. Yeah, it's a special rule with sine. No. Good? So yeah, we've got a pattern here. When we do the derivative of each of these, we multiply by that a value. And the nice thing about that a value is it's just a number, no variables. Because derivatives and integrals get messy the more variables you add, right? Yeah, oh, I can make, here, I say find the derivative. And if I add more numbers, 2 times 3 times 4 times 5 times 6 times x, no problem, right? Find the derivative with respect to x. That would be no problem. Find dy dx if I add more variables. So we'll assume these are all variables. You would have a major product rule and implicit differentiation going crazy here. Would that be fun? No. If those were all, if A was a function of x and B was a function of x, this would be really long-winded and hard. The more variables you add, the more difficult the derivative, and the more variables you add, the more extremely difficult the integral, because integrals are more difficult than derivatives. So we could do the product rule for this. Hello. If we look at the indefinite integral then, working backwards, if all of the derivatives have that multiply by a, the opposite of that multiply by a, to work backwards, is a divide by a. So we notice that if you have the ax plus b, this whole thing, ax plus b, you're going to have to compensate for that by dividing by a. Because the derivative, you still are going to have the ax plus b in your answer, but the derivative of that would have a chain rule, which would multiply by a. So to get rid of that extra multiplying by a, we divide by a. And so this is the general product rule one. So find the indefinite integral of the cube root of 5x minus 4. First of all, we're going to write this out with a power, and we notice we've got 5x minus 4 and ax plus b inside of that 1/3. So when we integrate this, we add 1 to our exponent and divide by our new exponent. And we're going to also have to divide by 5 plus c. So we still have our integration rules that we learned from before, but now we have to add a divide by 5. Now this is a complex fraction. On the bottom I have 20 over 3. Multiply by the reciprocal, and we get 3/20, 5x plus 4 to the 4/3. Every time you integrate, if you're like unsure if that looks right, you can always take the derivative of it afterwards, simplify, and see, do I get 5x minus 4 to the 1/3 if I do that? If I bring my 4/3 out in front, and then subtract 1 from the exponent and do the chain rule, does everything cancel out? Does it work out? So integration is nice that way, because if you're unsure, you can always, with your answer, take the derivative. Of course, if you make a mistake doing the derivative and you had done it right to begin with, I guess that would be really bad, because then you would erase everything and do it over and over and over again. So again, just like with derivatives, we take a moment to rewrite things in a form that we can integrate. And now, add 1 to the exponent, divide by that. You would have a chain rule, so the opposite would also mean we'd have to divide by 9 plus c. So just like we can do the power rule, we can now add logarithms, exponential functions. We'll do an example of those, and then we'll add sine and cos as well. Find the integral of this. Now, this is where I think with the ax plus b and the natural log, things get tricky because they really get hidden well. This doesn't look anything like a natural log when you look at it. So I mean, the power rule, at least the power rule produces a power, so they kind of hint to each other. But this doesn't look like anything like a natural log. So to recognize that this is the same as 1 over 3x minus 5, you could bring that 15 out in front. And 1 over, and now we have the ax plus b on the bottom. Means that we would have natural log of 3x minus 5, but this would be a chain rule which would multiply by 3, so we compensate by dividing by 3. Of course, you could simplify this. 15 divided by 3 is just 5. So I'd like you to try this one. All right, check your work. So the e to the x will stay exactly the same. And then we have to compensate for the fact that there would be a chain rule, so we divide by negative 3. And of course, the same thing happens with sine and cos. In some ways, what I'm writing here, earlier we just had kx. Can you see that kx is just an ax plus b form where the b is 0? And that b never factors into the next part of the equation, other than the fact that you have it up there again, but the only compensation you're going to have to do is divide by a. Find the indefinite integral of 3 sine of 6x minus 7. That 3 out in front doesn't affect the answer. That's just a constant. The integral of sine is positive or negative cos. Negative cos, so we'll have a negative 3 cos 6x minus 7. Compensate by dividing by 6 plus c. Could simplify that if you want to, or you could just leave it like that. We'll do one more example. Integrate negative cos 9x minus 1 that'll be negative sine 9x minus 1. Compensate by dividing by 9. All right, we are going to take 10 to 15 minutes to work on this.